Hello. In this video, we're going to learn what the integral of 1 over x is, and we're going to work on some integrals that kind of look like that. Now, does everybody remember the power rule of integration, which is a cookie cutter formula that tells us how to integrate x to the n? So x to any power dx is equal to x to the n plus 1. The power goes up by 1, and then you divide by n plus 1. That's in order to cancel the n plus 1. When you take the derivative, it'll cancel, it'll look really nice, you'll get the x to the n back. Right. So we have this rule, but did anybody notice that there's one special value of n such that this rule is not going to apply? Can you guess what it is? Do you already see? N equals minus 1, right. So if you remember our pre-calculus skills, when you're dividing, you can't divide by 0, not ever. And if you let n equal minus 1, that's minus 1 plus 1, and that's a divide by 0 right there. Okay, so this rule actually works for every single value of n that you can think of as long as n does not equal 1. So really this rule comes with the caveat that n cannot equal minus 1. Otherwise you'd be telling me to divide by 0, and I'm not going to do that. Okay, so let's see, 1 over x, does that sound familiar as anybody's derivative? Who has a derivative of 1 over x? Who was it? It wasn't a polynomial, it wasn't a power. It was actually the log function. Remember that from a couple weeks ago maybe? The derivative of ln of x, where ln is log in the base of the natural number e, log base e, turns out to be just 1 over x. Oh yeah, that's great. Okay, but actually this only works, keep in mind, on the domain where x is positive, is greater than 0, and that's because you can't take the log of a negative number, right? So this formula only works over positive x. But when I'm asking you to integrate 1 over x, really the question is the integral of 1 over x dx is equal to what? I'm not necessarily telling you that x has to be greater than 0. X could be less than 0. Maybe x can't be 0 though. It's kind of implied that x is not equal to 0 because again that would be a divide by 0. But it doesn't say x has to be greater than 0, right? So where's my rule for when x is less than 0? Okay? Similarly, if I consider the log of the function minus x, where my new domain would be the negative numbers, see if my domain is negative numbers, then I can't take the log of x, but I could take the log of minus x because then it would be a positive number on the inside, right? So if I take the derivative of this, then that's going to be a chain rule. It's a composition of functions. The inside function is minus x, the outside function is log. So 1 over the derivative of the inside function times the derivative, 1 over the derivative of the, 1 over minus x, okay? Times minus 1, which is the derivative of minus x. The minus cancels with the minus over there, and once again you get to 1 over x. The story is, whether you take the derivative of log of x or you take the derivative of log of minus x, it doesn't matter. Either way, you end up with 1 over x. That takes care of both parts of the domain, whether x is greater than 0 or x is less than 0. And we're all in agreement that x shouldn't be 0, because that would be 1 over 0. Kind of a crazy thing to ask me to integrate. Okay? So what's our rule going to be? What do you think? Oh, here it is. The integral of 1 over x dx is the log of the absolute value of x plus c. Absolute value, I haven't seen that function in a while. But usually that function comes into play when you have to do different stuff, whether your number is positive or negative. And you notice we did have to do something a little different depending on if it was plus x or minus x. So if we put the absolute value right here, then that absolute value makes this work out for both x is equal to greater than 0 and x is less than 0 for all x not equal to 0. Okay? So putting the absolute value sign around the x before I take the log of it, so keep in mind you absolute value it and then you log it, that makes this work out for all x not equal to 0. Well, what was the log of 0, by the way? What was the log, the ln of 0? Does not exist, right? I hope you remember that. If you type in your calculator is going to get upset. Does not exist. It goes towards minus infinity, right? What was the log of 1? What was it? Log of 1 was 0, right, because e to the 0 is equal to 1. Okay, you might have to go watch those videos again if that is confusing. But if you feel like you're ready, I would like to show you some examples of this on some functions, okay? So first of all, let's just try to integrate maybe 4 over x dx. Okay, you can use that rule. That rule will be there for you. What's the answer? Well, this one doesn't have a 4 in it, so it would probably be nicer if I just got that 4 out of the way so I didn't have to deal with it right now. Okay, now I'm going to use a formula just like this. That's going to be 4. The 4 carries through. Log of absolute value of x plus c. Got it. Awesome. Am I right? Am I right? Take the derivative. The derivative of log is 1 over x, so the derivative of 4 times log is 4 over x, right? And that's what I was asked to integrate. So that's perfect. Okay, so now let's try another one. How about the integral of 1 over 3x dx? Ask yourself this. Are you ready to apply this formula right now? Are you ready? Now on this one up here, I wasn't ready to apply that formula until I pulled the 4 out of the way. Are you ready to apply that formula on this right now? No. What can you do that will make you ready right away? Get rid of that 3? Right. So actually, if you see it like this, 1 over 3 times x dx, you can see that there's a 1/3 right here, and then there's just the 1 over x dx. Alright, if you have a constant that's in your way, try to get it outside the integral and then get to a point where you have known formulas that you can apply. Alright, and so the integral of 1 over x is equal to log absolute value of x, and then there's the plus c, and there you go. That's the answer right there. Okay? Is everybody happy with that answer? Everybody, is that exactly how you would have done it? Actually, I have taught this class before and seen people go a different way on this very same problem, so I'm going to show you an alternative route, which is not necessarily wrong, but it's a long cut. It's not really, this is the shortcut way right here on this integral, but an alternative route to go on 1 over 3x dx would be considering a u substitution situation. Did that come across your minds at all? Maybe for some people you were thinking, well, I have 1 over some stuff, right? So if I let u equal that stuff, 3x, and then the du was equal to 3 times dx, then really I would have 1 over u. And I know that the integral of 1 over u would be the log of the absolute value of u. Okay, let's see how this works out. I mean, if math is true, then whatever we get out of this should definitely be equivalent to this. So I wonder if this is going to work out. Alright, so this would be 1 over u, and then what am I going to put instead of dx here? If du is equal to 3dx, that means dx is equal to du over 3. Right, so then I have to replace the dx with the du over 3. Okay, and once again, you see I've got that 1/3 term, that's a multiplicative term, that can just come right outside the integral just like that. Then I'll have 1 over u du, and so that's going to be 1/3 the log of the absolute value of u plus c. Alright, I'm going through this u substitution for practice, so I'm just really good at u substitution by the end of this whole class. The very last step is replacing the u with the function of x that I called it, which is 3x plus c. Oh man, oh geez. Is math breaking right now for you two? Is this okay that I actually, one way I concluded that it was 1/3 log of x, and then the other way I concluded it was 1/3 log of 3x plus c? Is it right? Confusingly, yes it is. It's actually the same thing. Because the fact of the matter is, log of the absolute value of 3x, using the properties of the logarithm, is the log of the absolute value of 3 plus the log of the absolute value of x. Remember, if you have the log of a product, that's equal to the sum of the logs. Okay? So actually, we could see this function in another way. We could say that this, maybe that's not my final answer yet, if I choose to use this formula right here, I can say that's the log of 3. Now I'm going to drop the absolute value on the 3 because 3 is already positive. I don't need to take the absolute value of 3. That's just 3. X, I'm not really sure if that's positive or negative, so I'm going to hold on to that absolute value if I'm not sure if my quantity is positive. Okay, plus C, alright. And now look at this for a minute. The answer that I'm trying to give says that I have the log of 3 divided by 3 plus 1/3 log of absolute value of x, which I have right here, plus c. Okay, or rewriting that, that's 1/3 log of absolute value of x plus log of 3 plus c. Notice that what I did right here is I rewrote it with the functional portion here and then the constant portion, which is actually log of 3 over 3 plus c, over there. Do you guys remember what the plus c means? It means plus c, where c is any real number. So it's plus a constant. So actually what I'm claiming is that this boxed answer right here is exactly equivalent to this boxed answer right here. They just have different values for their plus c's. They're just different plus c's. Like this one is called plus c. This one is called plus c plus ln of 3 over 3. But that's just a constant. So what we generally say is you can just absorb these together and combine them and then just call it a plus c. Okay? If you want, you could have called this C1 and then called that C2 or whatever. But what you're experiencing here is just that there's a little dangling constant and it just gets absorbed into the constant of integration. If I had an initial value problem, then I could use that initial value to solve for the plus c, and I'd still get the same answer either way. Yeah, it's a little misleading, huh? Okay, let's go through a little more practice with this, and this is also lots of great practice on U substitution with different functions. You can see U substitution isn't just for polynomials to a power. It's actually a very general method which is used all over the place in mathematics. Let's take this integral for size. Now usually the dx is over on the side, but you can also put the dx on top of a fraction. In this case I'm asking you to integrate the function 1 over 2x plus 3 times dx. Sometimes it'll be written that way. Sometimes it will be written this way. Now this is an instance where I kind of have a constant times my x, so I want to get rid of that. But I have also a constant added on the bottom, and so I can't just pull out the 1/3. Like on this one, you saw the shortcut was to take this 1/3 and pull it right out. I can't do that anymore because it's not just a 2, and then it's plus 3 as well. So there's no other way to do this one except to take the direct root of U substitution. There's no shortcut when your linear function has a additive constant right there. Okay? So let's see, what are we going to do? U equals what? U equals all the stuff on the bottom. That's right, because I want to be left with something that looks like 1 over U. Just like over here, 1 over U. Okay, and then my du is going to be 2 dx, right? So I'm going to, this is step 1 of U substitution. Step 2 is I'm going to replace the bottom with the letter U because that's how I defined it. And what am I going to put instead of dx? Because du is equal to 2 dx's. So 1 dx is actually just half of a du. du over 2, right? Okay, so that's step 2. And then in step 3, I'll pull the 1/2 out, and I'll integrate 1 over u du to become, carrying the 1/2 through, the log of the absolute value of u plus c. Okay, and then in my final step here, I will rewrite that using the function of x that I started with. And don't forget the absolute values. You need those in place because x isn't necessarily a positive or negative number, and so 2x plus 3 is not necessarily positive or negative, but whatever goes into a log has to be positive. So don't forget the absolute values there. And then that's the answer. Go ahead and check that answer by taking the derivative in the secret step 5. I'll just leave that to you guys to practice at home. Okay? Alright, one more. Let's go for one more of these so you can kind of see some other types of integrals which may not look like they're in the 1 over x form, but once you get the idea of U substitution, then you see that they are in fact in the 1 over x type form. What about this? The integral of 6x squared divided by x cubed plus 4 dx. Oh boy! What kind of function is that? Polynomial? Rational function. That's right, it's a rational function. It's the ratio of two polynomials. Now you're telling me I can integrate rational functions? Oh, well, actually, 1 over u is technically a rational function. It's also a power function. But that's what we're going to do with this, is we're going to use u substitution to turn it into a 1 over u type of integral. Okay, let's get started. What do you guys want to use for u? What do you think I'm going to write down? U equals what? Now, whatever you guess for u, you should be able to see its derivative, maybe off by a constant, somewhere in the integral as well. Right. So do you want to guess the top? No. You want to guess the bottom part for u. That's right, because the derivative of x cubed is x squared. Right? And I see an x squared type of thing off by a constant. I'll deal with that. But that's why I know to guess that u is the bottom term, is because I can see some sort of form of its derivative inside the integral as well. Okay, cool, but unfortunately not so cool. I don't exactly have 3x squared dx. I actually have 6x squared dx. So if I just times this by 2, this is step 1 of u sub, then I'm going to get the statement that 2 du is equal to 6x squared dx, and that's what I have right here. Okay, so I'm going to replace my numerator, 6x squared dx, with 2 du's. That's how many du's it is. So I have 2 du over u, or if you like, bringing the 2 to the outside, du over u. Okay, or 1 over u du, whichever way you prefer it. That's step 2. And then in step 3, I'm just going to leave the 2 floating on the outside. It's going to be log of the absolute value of u plus c. And then to finish it off, you just have to replace u with what it was, x cubed plus 4 plus c. And there you go. Do you want to check that together? How about let's do the secret step 5 on this one and check and make sure that this is certainly the answer that we thought it was supposed to be. Okay. So my secret step 5 right here, I want you to take the d dx, the derivative of what's written right here in the box. Go ahead and do that on your own, because that way it'll be most satisfying, right? Did you see it? Well, if you didn't see it, there's got to be something going on wrong, so let's go through it together. The 2 just carries through, right? Now if I have to take the derivative of the log of something, the answer starts like 1 over the thing inside the log. Okay, so that's the start of it. But then don't forget the chain rule. Then after I do the 1 over part, the derivative of the inside has to appear next to it, just like that. And then when you rewrite that all out, you get a 6x squared divided by x cubed plus 4. Yes, that's perfect. That's exactly what I was asked to integrate. Don't forget the plus c, and you're good to go.